Okay, so we are moving on. We're still in our circles unit. Let's skip the do now. We have some more definitions that we have to go through. The first one is a blank is an arc is the curved path between any 2 points on a circle. So when you think of an arc, you're basically thinking about the rim of the circle, this outside edge. All right, so we're talking about an arc is between any 2 points on that outside edge. So it's curved. It's not a segment because it's curved. That's called an arc. Okay. A central angle is an angle whose vertex is at the center of a circle. So a central angle has to start, let's call this circle O. So there's our center. A central angle is an angle whose pointy part, the vertex, is at the center. So something like that would be a central angle. Now, if you notice in a central angle, the sides of that central angle are radii, and that will always be the scenario. The arms of the central angle will always be radii of the circle. Okay, next definition. A blank is an arc whose points are on or between the sides of a central angle. A minor arc is an arc whose points are on or between the sides of a central angle. So basically, if you look at the central angle right here, we have central angle AOB. The minor arc is the arc that the angle is basically eating. If you think of the angle as like a crocodile mouth, it's the arc that the crocodile mouth is eating. A minor arc is always less than 180 degrees. Always less than 180 degrees. Okay, let's turn the page. A major arc is an arc whose points are on the outside of the central angle. So basically, if you're looking at the path from A to B, that shortest distance is called the minor arc. But there's another path from A to B, right? Isn't there a longer path from A to B? That longer path from A to B is called the major arc. Okay. A semicircle is an arc whose endpoints are at the endpoints of a diameter. So a semicircle is half a circle. A semicircle is half a circle. And there really is no minor versus major. You could look at it however you want to look at because it's equal to 180 degrees. So a semicircle is half a circle, and we know a whole circle is 360 degrees. So a semicircle has to be half of 360 degrees, which is 180. So a semicircle is always 180 degrees, half of a circle. All right, the way we're going to shortcut is using symbols. So the symbol for arcs is sort of, literally, you're just creating an arc, is used to label arcs. The minor arc joining AB is called arc AB. So you just draw AB, the pathway between there, and then draw an arc over it. So now you might think, well, how are we going to distinguish between the minor arc AB, so the short route to AB, and then the long route to AB? Well, when we're talking about the major arc or the long route from A to B, we're going to add in a third point. So it would be AXB. Okay, so let's go through and name all the things we know. So let's name a radius. Even though there might be more than one, let's just name one. So I'm going to choose AC as my radius. We could have chosen CB or CD. Those are also radii. A diameter. Remember, a diameter has to go through the center of the circle, and the endpoints have to be on the rim of the circle. So diameter here would be dB. Let's keep going. A chord. Remember, a chord is a segment whose endpoints are on the rim of the circle. So I'm going to choose chord DE as the one I'm going to list. The diameter, I'm sorry, DE is a chord. The diameter DB is also a chord. So now let's name some central angles. So remember, a central angle, its vertex has to be at the center of the circle. So I'm going to name central angle with 3 letters, A, C, D. So I'm naming this central angle right here, angle A, C, D. Remember, the pointy part of the angle always has to be in the middle. The other central angle is going to be ACB. Okay, now let's name some minor arcs. Remember, the minor arc is the arc that the central angle is eating. So if we're looking at angle ACB right here, that central angle, the minor arc it's eating is arc AB. Now we want to name another minor arc. Well, if we're looking at central angle ADC, this central angle right in here, which arc is that eating? It's eating arc A to D. So arc AD is also a minor arc. Now we want to name 2 major arcs. So remember, the major arc is the long way around. So let's say I want to talk about the pathway from A to B, but take the long way around. So I'm going to start at A. If I'm going to take the long way around, I'm going to start at A, I'm going to go past D, and then go to B. We don't want to do 4 letters. Even though there's a point E in that path, we're only choosing D or E. It doesn't matter which point you choose, but you're only choosing one of them. So we're starting at A, going past D, ending at B. All right, now let's talk about the major arc that covers the path from D to A, or A to D. So let's say we're starting at A, but this time we're going to take the long way around. So we're going to go from A to B to D. Remember, we're only putting 1 extra letter in, not 2. So we're A, B, D is another major arc. Now the last one we want to talk about is a semicircle. So a semicircle is half a circle, so it gets split by the diameter. So a semicircle, I will name it as a major arc. Since a minor arc technically has to be less than 180 degrees, we'll name it as a major arc. So I'm going to call it DAB. All right, moving on to the next page. All right, definition. The measure of a minor arc or semicircle is the same as the measure of the central angle that intercepts the arc. Definition. The measure of a major arc is 360 minus the measure of the minor arc with the same endpoints. So, for example, here we have find angle ABC. Well, what we just said by these definitions is that the central angle and the minor arc that it eats has to have the same degree. So if arc AC is 20, then angle ABC is also 20 degrees. Once again, we want to find arc AC. Well, arc AC is going to be the same as its central angle. So if the central angle is 110, arc A to C is 110. Now we want to find the measure of arc ABC. Well, ABC is a semicircle, and we know all semicircles are 180 degrees. Okay, let's keep going. So here we have find arc AC and find arc ADC. So I'm going to start with AC first. If you see the central angle ABC, central angle ABC is 10 degrees, so arc AC is 10 degrees. Now we want to find the major arc that goes with arc AC. So the major arc is going to be 360 minus 10, which is 350 degrees. So this time I'm working a little bit backwards. I'm telling you that the major arc ADC is 300. So to complete the circle, the minor arc A to C has to be 60, right? Because a whole circle is 360 degrees. And that means the central angle ABC has to be the same as the arc it's eating, so that's also 60 degrees. And last but not least, find ADC. Well, ADC, once again, we have a semicircle, which means angle ABC is the same 180 degrees. All right, moving on. Angle BFC, angle B, we want to find angle BFC. Well, how are we going to find that? We know it's circle F, which means F is the center of our circle. So what I really hope you realize right here, let me highlight it for you, is that A to C is a semicircle, which, A to C is a diameter, which means it's going to split this circle into two semicircles. So from A to C is 180 degrees. Now, we know that angle AFB is 35, and we want to find angle BFC. Well, there's our straight angle right there. So we're going to do 180 minus 35. We're going to do 180 minus 35, and we are going to get 145 degrees. All right, let's keep going. Now we want to find arc CD. So arc C to D. I'm sorry, let's go horizontal first. Let's go to DFC. So here we have arc D to F to C. Where am I looking? DFC, that's angle DFC, which is this angle right here. If you notice, angle DFC and angle AFB, these are vertical angles. They have to be congruent, which means this is also 35 degrees. All right, let's erase some of my highlighting since it's getting a little bit distracting. So just label what we know. We know this is 35. We know this is 145. All right, and let's move on. I want to find arc CD. Well, arc CD is the same as its central angle, so we know this is also 35 degrees. And now we want to find arc BCD. So now we're talking about a major arc because it has 3 letters in it. So B to C to D. Well, B to C to D, oh, there we go. There's our semicircle again. So we know that's 180 degrees. Now we want BEC. So BEC, let me erase some of this highlighting I've done. So arc B to E to C, B, E to C. So we are passing our diameter. Here's our diameter, which I'm highlighting in black. So we know that's 180 degrees. So we're going to take that 180 degrees and we're going to go 35 more degrees. So BEC is going to be 180 plus 35, which is 215 degrees. Now we want to find arc BC. Well, we already know arc BC is going to be the same as the central angle it eats. So here's our arc. Which central angle does it eat? The 145. So we know arc BC is 145 degrees. And last but not least, we want to find arc ED. Well, let's look over here. I know the diameter is B to D. So right here is a straight angle. B to BFD is that straight angle. And I have 2 out of the 3 angles. So what am I going to do? I'm going to add 92 and 35 and then subtract that from 180. And we are going to get 53 degrees. Okay, moving on to the next page. If you want to pause the video right now and solve these problems on your own, you can. I will go ahead and list the answers for you to check. Okay, just so you recognize that BE is the diameter here. So that's how we're getting ACE, because that straight angle is 120. And that's how we're getting on the other side, angle ECD is 130. Okay, let's move on. No new definitions, but just stepping up our algebra a little bit. We have circle E. That means E is the center of the circle, which means A to D is a diameter. Now they're also telling us that C is the midpoint of arc BD. Well, the midpoint of an arc is the same thing as the midpoint of a segment. It splits these two into two equal portions. We're told that AB is 9x plus 30 degrees, and that CD is 54 minus x. Well, if CD is 54 minus x degrees, then B to C is also 54 minus x degrees. Now we want to find the measure of angle AEC. Well, in order to find the measure of angle AC, we first have to solve for x. Well, remember, what do we have? We have a semicircle. We have a semicircle. So we know these arcs added together have to add up to 180. So we have 9x plus 30 plus 54 minus x plus 54 minus x is going to equal 180. Let's combine our like terms. If we combine our like terms, we're going to get 9x minus x, which is going to give us 7x. Then we're going to have 30 plus 54 plus 54, which is going to give us 138 equals 180. We are now going to subtract 138 on both sides. So we're going to get 7x is equal to 42. Divide by 7. We're going to get x is equal to 6. Obviously, this is not our answer. I'm going to take this 6 and I'm going to substitute it in. So 9 times 6 is 54, plus 30 is 84. So this arc and its corresponding central angle have to be the same. Now let's go to BC. So we're 54 minus 6. 54 minus 6, which is 48. Which means the central angle is 48 and angle CED is also 48. Now let's see what we were asked to find. We were asked to find the measure of angle A to E to C. So angle A, look at what I'm highlighting, EC. So angle AEC is not 84, it's not 48, it's 84 plus 48, which is going to give us 132 degrees. All right, moving on to our last page. So now we want to find a measure of an arc that is. So we want to find the measure of an arc that is half of the circle. So what does this mean? You might want to get a visual going on here. So here's our circle O. They want an arc that's half the circle. Well, half the circle means we're going through the diameter. So we know half a circle has to be 180 degrees. But let's say we couldn't do that in our head. We would do half times a circle, which is 360 degrees, and that will give us 180. So now we want to think of the measure of an arc that's 1/3 of the circle. So we could translate this exactly from words into symbols. 1/3 of. What mathematical operation goes with the word of? Multiplication goes with the word of, and a circle is 360 degrees. Now remember, when you're multiplying fractions, something we're allowed to do is cross cancel. So 3 goes into 360 120 times. So we're at 120 degrees is 1/3 of the circle. Let's keep going. Now we want 1/5 of the circle. So we're going to do 1/5 of means times a circle means is 360. Cross cancel again. 5 goes into 360 72 times. So we're at 72 degrees. All right, next one, we have 3/4 of means multiplication. A circle is 360. So once again, we're multiplying fractions. We're allowed to cross cancel. 4 goes into 360 90 times. But my answer this time is not 90 because I still have 3 times. So we're 3 times 90 is going to be 270 degrees. And the last one in this section is going to be 4/9 times 360. Well, 9 goes into 360 40 times, so now I'm left with 4 times 40, which is 160 degrees. All right, the last thing we're going to do today is sort of work backwards. So now I'm going to tell you the degree of the arc, and I want you to tell me what fractional part of the circle is that. So all we do for this section is, well, 30 degrees is how much of the circle. So we're going to say, well, 30 degrees out of 360. So you're just going to take your degree and put it over 360. And then like we do with all fractions, we simplify. Let's cross out those zeros. So now we're left with 3 over 36. We can divide by 3. So 30 degrees is 1/12 of the circle. Try the next one, 90. So I'm going to take that 90 degrees out of 360, cancel out those zeros. We are 9 out of 36, divide by 9, we are 1/4 of the circle. Okay, let's do a couple more. 150 out of 360. We are going to simplify that all the way down to 5/12. 72 out of 360, we're going to simplify that all the way down to 1/5. And 330 out of 360 will simplify down to 11/12. Right, so we are done for today's lesson. I'm not going to assign you any homework tonight. Tomorrow's assignment will be for you to complete some homework, and then we will continue on with circles. Have a great day. Talk more tomorrow.